Howdy. Howdy ho. Howdy hi. Howdy hi, howdy ho. Let me know you're here. Are you here? Are you here? Who's here? Who's here? Hey, Austin, Rachel, yay! Y'all are here, y'all are here. Good, 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 good. Thomas, yay! We're here. Just one lecture tonight, not two. So, should go pretty quickly. How was the homework? Nice and easy? Did you get good at logs? You know it's just an exponent, that's all a logarithm is. Just looking for the exponent. Can you read my shirt now? Hey, Jacob! Woot woot. Can you read my shirt? Hey, Amanda! Amanda's got to be here just in case. Since we keep going public, I keep letting anybody who wants to watch out for those trolls. Y'all just ignore those trolls. Let Amanda take care of them. Thomas, don't banter with them. Thomas. Hey, Robin. All right, grab some water and a hair tie. I don't know what the hair tie's for. Your hair getting that long? See if you can solve this. Oh, I was going to fix that and do a different one. Oh. Here, let me do a different one. I'll do that one in a minute. That was too hard. Let's start easy. Do this one. Let's start easy. Or here, let me do. I don't know. Let's just do that one. Do that one first. Do that one first. Do that one first. Do that one first. See if you can do that one. Then I'll go to the harder one. Who else is here? Where's Cheyenne and Cherish? They were just on Discord. They're bound to be on any second now. I'm convinced they'll be here. Any second. And let's see who else is missing. Fernando, he might be at work. That might be everybody. Marissa, is Marissa here? Missing Marissa. September, where's September? Did y'all figure out what X was? Did you figure out what my shirt said? Got two questions to you. What's my shirt say and what's X? See if y'all really are here. Or if you just like signed in and then walked off. So Amanda, did you work today? Were you actually able to help anybody? I'll talk to you since nobody else answered me. Oh, there we go. You don't know what my shirt says? X is 4 though. I do like that. 3 times 3 is 9 times 3 is 27 times 3 is 81. I like that. This sounds good. You don't know what my shirt says? Ignore all that. And e raised to the natural log of heart. So think about your homework. This was the one that gave everybody the most trouble. I was having to walk people how to put it in. Hey, there's Fernando. I was afraid you had to work tonight. No one to help. Watched lots of professional development then. Fun times. You don't remember what you did on your homework? Hey, there's Cheyenne. And I bet Cherish is there too. Just right beside you. All right, we'll get started then. Y'all will figure out. Y'all know what my shirt says. Come on. Just from context, what does it got to say? What does it got to say if it's in context? I mean, from that, what does it say? And then maybe you'll remember that when their bases are the same, their arguments are the same. So, yeah, you're right, love. Because remember, when their bases are the same, their arguments are the same. So I have e to the natural log of heart. This is an exponential form. If I want to put it in its logarithmic form, I'm going to write natural log base e of, well, I don't know what this is. I'm looking for that argument. So, this is in exponential form. It's equal to something. I'm putting it in its logarithmic form. Well, it's natural log of e, that base e, of question mark, I don't know what the argument is equal to this natural log of heart. Well, what does that question mark have to be then? It has to be that heart. That's what it has to be. Nah, you already got the bonus points, Cheyenne. Nobody else is going to get them. Too late. They did it wrong. The domain was wrong. I'm going to get it fixed. You already earned those points. But nice way to shout out to your friends. Nobody else caught it. They just turned in their word. Sillies. Oh, just let them know. Okay, just let them know. So on the homework, I'm going to let them know because they've already turned in their homework and they're going to have it wrong because they're just going to have copied me. And then I'm going to be like, but that's wrong. It was wrong. It was wrong. On the domain, I used this symbol on my domain, which means that it was actually included, but it wasn't actually included. That asymptote actually goes this way. The asymptote on my logarithms, it doesn't ever actually reach 0. So this should have been a parentheses. And also it should say is greater than 0, not greater than or equal to 0. Clearly when I made it, I made a mistake. Y'all are supposed to catch that. So now the people who turned it in just by copying mine. I'll be like, it's wrong. So check your domain there. All right, so tonight, this is basically what we're doing. We're going to have our variable in the exponential place, and we're going to have to solve for x. Or sometimes my variable will be in the logarithm, and we're going to solve for the variable there. So we're going to be solving for x in all of our equations tonight. And we're going to have exponential and logarithmic equations that we're looking at. Good. Good. Y'all are exactly right. So strategy 1, when we have this exponential equation, the first thing we're going to do is we're going to set their bases equal to one another. So whether you realized it or not, that's what you did here. You set their bases equal to one another. Yes, September, that's enough work to show. So you said that this 3 to the x is equal to, well, 81 is 3 times 3 is 9 times 3 is 27 times 3 is 81, so that's 3 to the 4th power. So x, when their bases are the same, we know their exponents are the same. We said that last time. And that's true here. When their bases are the same, these two have to be the same. So therefore, x has to equal 4. So our first strategy is just to make their bases the same, so we can set their exponents the same. Probably, but too much work, there's no such thing as too much work. There is such a thing as not enough work. But some of y'all are getting better and better at it. Shout out to Thomas. He's gotten where he can show his work really well. So proud. From none at all to, he's going to explain it. It's perfect. All right, so here's another example of that. I took this, here was the hard one I had up here, as our early bird, but then I took it back down. But we're going to do that same thing. So our strategy is to set our bases the same. In other words, this one has a 3. We want that one to have a 3 also. So to set their bases the same, I'm just going to rewrite that 81 as 3 to the 4th power. We said that there. That's just equal to 81. Now that their bases are the same, I can set their exponents to be the same. And then I'm just going to solve. So subtract 1 from both sides. Divide by 2. And x equals 3/2. Yay! Way to be, Rachel. You beat me to it. It's exactly right. Now, I always love solving because I can go back in and check myself. So let's do that. Let's check ourselves. If I put in, for that x, this 3/2, well, this 2 and that 2 become 1. So I have 3 to the 3 plus 1, which is 3 to the 4th power, which is 81. Check that out. It really did work. So I always like solving equations because I can check myself afterwards to make sure that I'm correct. So base is the same, exponents can be the same. Let's do another one. All right, I'll make it a little trickier. Hey, Marissa. Glad you're here, glad you're here. All right, so here I have 4 to the x equals 32. So now I want to set their bases equal if I can. My whole goal is when I have an exponential equation. By the way, what makes it an exponential equation is the fact that this variable is in the exponential position. That's where it is. It's up there in that exponential position. So I want to put their bases the same. I want to write them both with the same base. So let's see if I go by 4s. 4 times 4 is 16. Times 4 is 64. I just skipped over the 32. Yes, Robin. Strategy 1. Set their bases the same. I skipped over 32, so setting it to base to 4 doesn't work. But Rachel's got it. We can make their bases be 2. Because 4 can be rewritten as 2 to the 2nd power. And then 32 can be rewritten as 2 to the 5th power. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. This is a fancy way to say 4, that's 32. Now that their bases are the same, I can make their exponents be the same. So, here's kind of a big deal though. Remember that when you have a power and a power like this, you know, this 4 is raised to that x power, you're going to multiply those two. Here, it's kind of obvious, you just got 2 to the x, but if I had like a plus 1 out here, this 2 would have to distribute to both of them. So if you have some problems where when you rewrite your base down here to a power, if you've got some exponent out there that's like this, then you have to distribute this to both of them. So just be aware of that. All right, so here they're multiplying. Now their bases are the same, so I set their exponents the same. Divide both sides by 2. and x equals 5/2. Not too bad, right? Not too bad, not too bad. All right, let's do another. How about we do this? 7 to the x minus 2 over 6 equals the square root of 7. So again, my variable is in that exponential position. So this is an exponential equation. And I want to solve for x. First strategy is to try to set their bases the same. What's their base going to be here? What's their base going to be? Yeah, the great thing about doing the live stream is that if you just want to listen the first time, then later it's recorded and online, so you can always go back and take notes the second time. So put me on double speed and stop it when you need to take notes. Yeah, I like the 7. This one's already base 7. This one's base 7, but what's the exponent there? You know, there is an exponent. Yeah, that's right, to the 1/2 power. Remember that square root just means I'm raising it to the 1/2 power. So now their bases are the same. I just set their exponents equal. And once I have their exponents equal, I just solve. So remember when we're solving with the fractions, an equal sign fractions, I'm going to multiply both sides by the least common denominator to help get rid of my fractions. So here my least common denominator is 6. Remember, it has to be just as big as the biggest number. Hey, there's Cherish. So times 6 and times 6. So this 6 becomes x minus 2, and half of 6 is 3. Add 2 to both sides. Add 2 to both sides. And x is 5. Again, I always love these because I can go back and check it. 5 minus 2 is 3. 3 over 6 is 1/2. Oh, that's the square root. Yay! So our strategy is to set their bases the same if we can. So that's strategy number 1. So let me write that down somewhere. Solving, let me find a different blue. That blue is sad. Solving exponential equations. Strategy 1, if we can, set bases equal, then exponents are equal. So the first strategy is to set your bases equal, and then you know your exponents are equal. That's the first strategy. Your second strategy, your strategy 2, well, let's look at it. So here we've set their bases equal. If we can do that, that's nice and easy. But let's look and see what happens when we can't do that. So let me give you an example of one, maybe where we can't do that. So here I have 5 to the x equals 3. And notice that I can't break 5 down to set it to some other power. I can't break down 3 any to set it to some other power. So I can't set their bases equal to one another. So when that happens, we have to have a different strategy. And what our strategy is going to be is we're going to, yeah, I wish it was 3. Let's try that. If I put 3 in there, well, 5 times 5 is 25 times 5 is 125. So x itself is not 3. 5 to the third power 5 to the x power equals 3. I'm looking for what is that power there. So what we're going to do, the strategy we're going to do, is we're going to take the natural log of both sides. I mean, one way to do it would be to just put it in its logarithmic form. Here it is in its exponential form. We could just put it in its logarithmic form. We could say log base 5 of 3 equals x. That says the same thing, right? This says 5 to what power gives me 3? That's what I'm asking. 5 to what power equals 3? But it doesn't really give me an answer. Like, I need to know that. That's what I'm trying to find out, is 5 to what power equals 3? So, first of all, we could kind of estimate a little bit, because we could say we know that it is less than 1 because 5 to the first power would be 5. So I know that my x value is less than 1. But I can't tell you exactly what it is. I can just give you an approximation. And I can't even put it in the calculator because it doesn't have that base on there. Maybe they do nowadays, I don't know. Back in the day, they didn't even have that. So what we're going to do is we're going to use a second strategy where we take the natural log of both sides. We're going to take the natural log of both sides. Amanda, do they have a fancy button nowadays where you can put the base 5 of 3 in there? Or do you still have to take the natural log? I never used calculators, so I don't even know the answer to that question. Really, way back in the day, before calculators, we didn't have, in order to figure out these logs, we would use something called a log table, where we had the natural log. We could look on this table to find out the values of different ones. Yeah, good, Robin. It's going to be about there. But the way we're going to solve it is we're going to take the natural log of both sides. We're going to put it in terms of natural log. In other words, I'm going to take the natural log of both sides. So I'm going to take the natural log. Let me just do it this way. I'm going to take the natural log of 5 to the x. I'm going to take the natural log of that side. It's like taking the square root of both sides. Or it's like squaring both sides. Or it's like adding a number to both sides. You know, I'm using this operation. Remember that this is an operator. I'm going to take the natural log of both sides. So some of the really, really fancy ones can. All right. Now, I'm going to use my power rule that we learned last time to make this multiply out front, to kick him out front. So use that power rule, and now your x is no longer in its exponential position. We really like the natural log, though. It comes up in lots of different areas. So being able to put it in natural log is a handy thing to be able to do. But it is true that it's also equal to log base 5 of 3. That's what x is going to be equal to. Now, I need x by itself. So I'm just going to divide by this number. You know, this is just a number. E to what power gives me 5? Well, it's a little bit more than 1 because E is 2.7. So to get the 5, it would not quite be 2 because that'd be 7.2-ish. So I know that this is a little more than 1. I'm going to divide by that little bit more than 1. I'm going to divide by that number on both sides of my equation. so that x is equal to the natural log of 3 divided by the natural log of 5. Again, this is just some number. It's about 1, because e is about 3, and this is a little more than 1. So if you divide that 1 by a little more than 1, you're still going to get that like 0.68-ish. So the natural log of 3 divided by the natural log of 5 turns out to be the same thing as log base 5 of 3. Those two numbers are about the same. We're going to leave it, though, in this exact form, right, like this. Now, you're going to be tempted, I know especially Austin in September, you guys, you two that like to break up family members, are going to be tempted to make these natural logs go away. Don't do it. These are operators. They're not, this is not a number in itself. It would be like if I had 3 plus 1 over 4 plus 2, and I decided to make the plus signs go away. That would be weird, right? Don't do it. Don't do it. Do not cross that out. All of this is one number. All of this is one number. It'd be like chopping his head off. Don't do it. Make that an L, like that. You can write in cursive, that works. Yeah. I know, calling you out like that. It's because I know you. You know exactly. So don't cross that out. It's an operator, just like that plus sign. Or another one that I like to compare it to is this, you know. If you're taking the square root of some number divided by the square root of some number, and you go, well, I'm just going to get rid of those square roots. We can't do that. No. And that's the same thing as these natural logs. They're like a square root. They're an operator like that. They're like that plus sign. Don't do it. Stop it. Okay, so let's do a couple more like that where we can't do strategy 1, so we have to do strategy 2 and take the natural log of both sides. So here's another example. We have e to the x equals 107. So, you know, what am I raising e to get to 107? I can't make this base also be e. So I'm going to take the natural log of both sides. Take the natural log of this side. Take the natural log of that side. Use your power rule so that you have x times this exponent times that exponent. Or maybe you were looking at this, and just like my shirt, you were like, their bases are the same, so their exponents have to be the same, because this is just a fancy way to say 1. So I have x times 1, which just leaves me with x. I'll write it out, though, in case somebody looks away. X times 1, so that's just equal to x. Or you could have just said, look, their bases are the same, so this is just equal to x. Or, look, if we were putting this in logarithmic form, wouldn't we have written natural log? Because our base is e of our argument is equal to our exponent. So we got the same answer just by putting it in its logarithmic form. So strategy 1 is we set their bases equal. Strategy 2 is we take the natural log of both sides. I'll make it a little bit trickier. Make it a little harder. Same kind of idea. We'll even use that same 107. The only thing I added to that is that 9 out front. It's the only thing I did. So what we want to do is we want to get our exponential expression by itself. We want to isolate him first. So to isolate him, we're going to get rid of that 9. And the way we get rid of that 9 is divide by 9. They might be. I don't know, Robin. I'd have to look into it. But it's possible. Logarithms are definitely used for lots of different things. Lots and lots of different things. And we're seeing it with the virus right now. We all saw that in your last task where we started talking on a logarithmic scale as opposed to the exponential. Now, here, I'm going to divide both sides by 9 so that I have e to the x equals 107 divided by 9. I'll look into it, Robin, and see. Then I'm going to take the natural log of both sides to help me get that out, because I can't put that in the e in that base, in the base of e. So instead, I'm going to take the natural log of both sides. And you could kick that x out front like we did here, or you could just go, when their bases are the same, their exponents are the same. So this is just going to be equal to x. And it's equal to x, the natural log of 107/9. Me too, now I'm curious. I don't know how they come up with that. We only want to write it with one logarithm, so maybe you're noticing that this is a quotient. We could use the quotient rule, but just leave it. We want to write it with one logarithm. So just leave it there. It kind of helps us to figure out our number, if we're trying to, if I'm trying to approximate, I'd say, this is 3 to what power gives me 107? Because e is about 3, right? So it's like 3 times 3 is 9, times 3 is 27, times 3 is 81. So it's going to be a little more than 4 to get up there. So this is like 4. The top part is like 4. And then I know I'm going to subtract whatever the natural log of 9 is. Well, 3 times 3, so it's about 2. So this is going to be about 2, is about how much that's going to be. Or you could just do the division. 9 goes into 107 about, I don't know how many times. You tell me. 2 times, about 12 times. So again, e goes into 12 a little more than 2 times. So we can start to approximate what it is. All right, we'll make it a little trickier, a little tougher. How about I do e to the 4x minus 5 equals, minus 7 equals 11,243. Just making up a number there. Okay, the first thing we want to do, we can't set our bases the same. I'm not going to be able to set that into base E. So the first thing I'm going to do is isolate my exponential expression. I want him by himself. So to get him by himself, I'm just going to add 7 to both sides. I'm going to add 7 to both sides. So you have e to the 4x minus 5 equals 11,250. Now I can take the natural log of both sides. So take the natural log of this side, take the natural log of that side. So once you get your exponential, where you have your base and your exponent by itself, that exponential equation, expression by itself, then you can take the natural log of both sides. This kicks out front, or it just becomes 4x minus 5 is equal to the natural log of 11,250. Remember, you know, it's e to what power gives me that. This whole thing's in the argument. Now, what's x by itself? So I'm going to add 5 to both sides. But when I add 5 here, this 5 is not going to be added into that argument. That argument is part of this. If you know, it's the natural log of this makes that number. This is all one thing. So don't add that parasite in there. You know, don't chop his head off, and don't add a parasite in there. He's off to the side. I usually like to write him out front, just so that I don't make him add in later. That's right, September. It's because e to what power gives me e, or it's just the first power. So this rolls off, and I've got this times 1, which just gives me that. So yeah, it just kind of makes it disappear. So here I have 4x. I'm going to put this 5 out front just so that I don't like accidentally add him in there. Then I almost have x to it by itself. I just need to divide by 4. So I have x equals 5 plus whatever that number is, all over 4. And that's my final answer. There it is in exact form. We could give an approximation. We could throw that into the calculator, find out what that number is, add it to 5, divide by 4. But I'm happy with this. Just leave it there. Leave it there. All right, so when we have an exponential equation, 2 strategies. Set their bases equal, and then when their bases are equal, their exponents are equal. And then you just solve. If you can't set their bases equal, then use strategy 2 and take the natural log of both sides. Okay, so they're solving the exponential equations. Now we're going to solve logarithmic equations. Yeah, those operations are like wedding rings. They keep them together. They join them. They're just as difficult as those wedding rings. Okay, now I'm going to look at some logarithmic equations. But before I do that, let me just look at, for a second, something like this. Y'all graphed logarithmic functions last time. You know, you graphed maybe something like this, where you had log base 5 of x equals y. And the way you graphed that is you said, well, I know my exponent would be 5 to the x equals y. You wrote that down, and then you just found the inverse of it, right? Okay, so today I'm going to look at what if we did some transformations of that. Oh, and by the way, when you graphed this, on all the ones you graphed, there was a vertical asymptote where x equaled 0. In other words, my domain was restricted. My domain on all these logarithmic equations, it was from 0 to infinity, and not including 0, so it needed to be a parentheses. Or where x is greater than 0. So, yeah. So my logarithmic equations have this restriction where inside this argument, my x values inside the argument cannot be less than 0. They cannot be negative. I need this argument to be a positive number. So I'm going to look at a transformation. So what do you think would happen to this graph? If this is what that graph looks like, what would happen to this graph? How would that look different? What do you think? You know a little bit about transformations now, so what should happen to my graph there? I like it. You're right. It's going to move it to the left 2. That's exactly right. Because it's in here with our x. Our x is live, so instead of going that way, we go this way. It moves it to the left 2. And what happens is, y'all are geniuses. And what happens is my domain then is restricted. It moved it over 2. So I now have this new vertical asymptote where x equals -2. And my graph now looks like this. So my domain goes from -2 to infinity. My domain is still restricted. Okay, this is going to be important today as we solve our equations. If we get some value where x is less than 2 as I'm solving, then I'm going to have to say that's not in my domain and that's not a solution. So that may happen a few times where I get something that's not actually a solution. I have to be careful to make sure that my x value is actually in my domain. So we're going to start by looking at the domain first in all of these logarithmic equations, and then solving it and checking to make sure that our x value actually is in that domain. Oh, yeah, less than 2. Yeah, negative. Huh? Huh? Oh, if x can't be less than -2. It can't be over here. So let me show you. Let me do a better job. That's kind of the visual, though, of what's happening. So let me give you an example, and it'll make more sense. Maybe, not really. So let's say I have log base 5 of just that, x plus 2, and I know that that is equal to 3. My domain here is restricted. Now remember, inside this argument cannot be negative. So I'm going to do with it kind of like I did with the inside the radical. When I was finding the domain underneath the radical, we said that underneath the radical had to be greater than or equal to 0. And this too has to be greater than or equal to 0. It has to be positive. Inside that argument has to be positive. It can't be negative. So my x value must be greater than or equal to -2. When I get down to the bottom, I'm going to look and make sure that my x value actually is greater than or equal to -2. Okay, but how do we solve this thing? Well, you kind of did that this last week, right? If I just had log base 5 of x equals 2, let me make it even simpler. In this case, what's my x value equal to? Can you tell me what my x value is equal to? Think about, right now it's in logarithmic form. Can you figure out what would be in the argument to make this true? What would have to be in there to make that true? It's a little bit hard. I bet you can do it though. Think back to that homework. It's kind of going backwards. Good, Robin. It would have to be a 25. Log base 5 of 25. 5 to what power gives me 25? Well, it's 2. So notice that you're doing 5 to the second power gives you that 25. So it's kind of backwards as what you did last time. I could put this in its exponential form and say 5 is my base, 2 is my exponent, and I'm looking for my x. And that's how we get it. So it is tricky. It's hard. So that's what we're going to do, though, is we're just going to use our exponential form to help us solve these. So here, if I'm putting this in its exponential form, well, my base is 5, my exponent is 3, and it's equal to the argument. Base, exponent, argument. Now I'm just going to solve for x. So 5 times 5 is 25 times 5 is 125. Subtract 2 from both sides. And x is equal to 123. Let's see if that makes sense. If I take that 123 and put it in there, 123 plus 2, 123 plus 2 is 125. 5 to what power gives me 125? Oh, it's a third power. Sure enough, that works. Now, I have to check to make sure that that's in the domain. Is this one okay? Is it greater than -2? Yes, 123 is bigger than -2, so that one's okay. It's not going to make my argument less than 0. We only have a problem if, when I get this solution, if when I put it in my argument, it makes my argument negative, then it's a problem. It tells me that that is not actually a solution. This one is. It checks out. We'll show you an example of that here in a little bit. All right, let me do another one. Here I have log base 2 of 4x plus 1 equals 5. So this time it's a logarithmic equation because my variable is in the argument. Before it was an exponential equation when my variable was in the exponential position. But here my variable is in the argument. And to get that variable out of the argument, I'm just going to use its exponential form. So I'm just going to rewrite this in its exponential form. Base 2, power 5, equals argument. Solve. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. Yay! Y'all got this. Subtract 1. $31. Divide by 4. And 31/4 is your x value. That's kind of nasty. But if we put that back in, and the 4's would cancel, leaving me with 31. 31 plus 1 gives me 32. 2 to what power gives me 32? The 5th power. Now I'm going to check to make sure it's in my domain. It should be because I just put it back in and it was positive. But let's just find the domain. So what is the domain of that guy? Well, that 4x plus 1 has to be greater than or equal to 0. So I subtract. It can't be 0. Get rid of that equal to. It can't be 0. It can't be equal to 0. That's what I did wrong on the other one. It's like 7 and a little. Yeah, that sounds good. It is about 7 and a little. You're right. Subtract 1 from both sides and you get a negative 1. X has to be greater than negative 1/4. The argument cannot be 0. 2 to what power gives me 0? There's nothing in there. There's not a power I can raise 2 to get 0. So it has to be greater than 0. It has to be bigger than 0. Look, my answer is bigger than negative 1/4. So this is in the domain. It is a solution. All right, let's do another. Here we have the natural log of the square root of x plus 1 equals, I lied, that's a 4, equals 1. The natural log of x plus 4 equals 1. Yeah, they're not too bad. Next week is going to be bad. It's all graphing and it's time consuming. And we're going to have a little heart-to-heart at the end. But I'm going to advise you to, as soon as you're done with this, start on next week's. And start by watching the videos. I'm trying to get the videos up. And so you're going to want to get started just because it's going to be a little bit tedious. We'll talk, though, at the end of the stream about getting started for next week. You're right, it will be. You're right. It's got this weird square root too. But we're going to do the same thing. First of all, I'm going to look at the domain just to check myself. So at the end, I can check it. So in the argument, that has to be greater than 0. Square both sides. It has to be greater than 0. Subtract 4, and x is going to have to be greater than negative 4. So here, my x value, when I get done, if I don't get something greater than negative 4, then I'm going to say that's not a solution. All right, so just kind of knowing what my answer has to be. It has to be bigger than negative 4. Then I'm going to use my exponential form to get that x out of the argument. So my base here is e. My exponent is 1. And my argument is the square root of x plus 4. I want to get rid of that square root. So I'm going to square both sides. So I have x squared equals x plus 4. Subtract 4 from both sides. And I have e squared minus 4 equals x. So let's look and see, is it a solution? Well, you know that e squared is about 7-ish. 7-ish minus 4 gives me 3-ish. Is 3 greater than negative 4? Yeah, it's greater than negative 4, so it is a solution. This one does check out. It is a solution. So far, they've all been solutions. We haven't had any problems with their domain. Let's do a couple more. Alrighty. Let's do this one. 7 plus 3 natural log of x equals 6. Can I add those two? Can I make this 10 natural log of x? Can I add those two together? No, that's right, I can't. They're not like terms. This multiplication has to happen first. And I can't put it in its exponential form right now either, because I need just the logarithm and the argument by itself in order to be able to put it in its exponential form. So what I'm going to have to do is get it by itself first. So to get it by itself, first I'm going to get rid of that 7. I'm going to send him off to play blocks. So send away that 7. And it leaves me with 3 natural log of x equals the negative 1. Divide by 3. Good. That's exactly right. Y'all got this. Divide by 3. So I have the natural log of x equals negative 1/3. Now, I just have my log with that argument by itself. So now I can put it in exponential form. Maybe I look at my domain first just to see, so when I get to the end, I'll be able to look to see if my answer's right. Well, x has to be, that argument has to be greater than 0. It's the only thing in the argument this time. So my answer just has to be bigger than 0, and if it is, then I'll be good. If my answer's positive, then we know that we're not in that we are in the domain, that our answer is a good answer. Okay, so I'm going to go back here. I'm going to put it in its exponential form to solve it. So e to the negative 1/3 equals x. Now what does that negative exponent do? What is the negative exponent going to do? And then, what does the 1/3 do? What does this mean, that negative of a 1/3? So that negative exponent flips it to the bottom, makes it a fraction. So I have 1 over e to the 1/3. Remember, that negative makes it perfect, guys. Good. And then you're right, that's the cubed root. So it's 1 over the cubed root of e equals x. So this negative 1/3 means that. Now, is that in the domain? Is that a positive number? Yes. You know, the cube is not a big number. It's a little bitty number, but it is still positive. Notice there's no negative out there. So this is in that domain. So this is a solution. Okie dokies. Let's try another. Log base 6 of x plus 3 plus log base 6 of x plus 4 equals log base 6 of 6. Let's try that one. That one looks scary. That one looks scary. Scary looking. Scary looking. It is scary looking, but we can do it. First thing I want to look at is just the domain. So I just want to talk about the domain first. So I know that this argument has to be greater than 0. Oh, but there's another argument here with x in it. This one also has to be greater than 0. Oh, that one doesn't have an x in it, so I don't have to worry about him because there's no x in that argument. It's just a number. It's already greater than 0. All right, so I know that my x has to be greater than -3, and my x has to be greater than -4. Well, if it's greater than -3, isn't it greater than -4? So this one's larger than that one. So if it meets this one, then it's meeting that one. So I can just say that the domain of that thing is x is greater than -3. So my answer just has to be greater than -3. You're right, Cheyenne. Over here on the right, log base 6 of 6, that's just a fancy way to say 1. You're exactly right. So really, this equation is just equal to 1. Way to see that. That's great. Then I can't put it in exponential form yet because I don't just have the logarithm and then with an argument and an answer. I want log just written one time with its base and argument equal to a number so I can put it in its exponential form. And right now I've got 2 of these logarithms. What could I do so that I'm just writing log one time? I only want to write log one time. What did we do so that we're just writing log once? Do you remember? You remember condensing it? So I just have log written one time. And this plus sign tells me that I can use the product rule. That's exactly it. Y'all got this. I love those, September, that you skip straight to my favorite thing to do, which is factor. Hold on to that because we're going to need it in a minute. Because 6 to what power gives me 6? Is just equal to 1. 6 to the first power gives me 6. So this is just a fancy way, 6 to what power gives me 6? It's just the first power. So that's just a fancy way of saying 1. And you're right though. Here, this lets me know I can use the product rule. It's this argument times that argument. When they're multiplying together, I can separate them, log of the first one plus log of the second one. Now that I have log just written once with the base and an argument and an exponent, now I can put it in exponential form. So I'm going to do that. I'm going to put this in exponential form. 6 raised to the first power is equal to this argument. But in order to be able to put it in that form, I have to get it down to 1 log. So you may have to use those rules to help you condense it. The rules you used last time, you might have to use to help you to condense it. Okay, now we do a little bit of algebra. X times x is x squared. X times 4 is 4x. 3 times x is 3x. And 3 times 4 is 12. Combine your like terms. X squared plus 7x plus 12. Now what? How do I solve x there? Here's the tricky thing. Anytime my exponent is greater than 1, I have to set this side equal to, that's right, I am going to F it. But before I F it, I have to make this side equal to 0. So I'm going to make this side equal to 0, and then I'm going to F it. You are so right. Good. So subtract 6. Y'all have got this. And now I'm going to F that. I'm going to factor it. My A is 1. My C is 6. My AC is 6. Factors of 6 that multiply, that add to be 7. Well, just 1 times 6 adds to be 7. Since my A was 1, I can skip straight to the punchline. You got this. Y'all got it. So now either this guy equals 0 or that one equals 0. Subtract. Subtract. And so either x equals -1 or x equals -6 to make this true. But let's go back and look at that domain. Remember our domain restrictions? It has to be greater than -3. Notice that one's greater than -3, but this one's not greater than -3. He is not a solution. If I plug him in here, it's going to make my argument negative. If I plug it in there, it's going to make my argument negative. This is not a solution. He's superfluous. This is my solution. If I put in -1, that's right, only -1 meets that requirement. So only -1 is my solution this time. So that's why we have to check the domain every time. Sometimes we get an answer that's not actually an answer. When we solve for it, we go, wait, that can't be an answer. It's not a solution. And it may not have a solution. In this case, there were 2 answers, so this one is the solution. But it is possible that you just don't get an answer, that there isn't a number that makes it true. All right, let's do one more that looks hard, but you can do it. And then we'll talk about next week. Okay, 3 log base 2 of x minus 1 equals 5 minus log base 2 of 4. So tell me what you see first. I have a headache today that I can't get rid of. I keep drinking coffee thinking it'll fix it, but it's not fixing it. But it's okay, because I need to stay up all night making the videos for next week. So after we're done with the homework, I'm just going to be making 1,000 videos tonight. Not 1,000, but a bunch. I already have a bunch made, but they're not all, I need more. What do you see? Yay! Oh, I like all those answers. You got lots of good answers. First of all, let's find the domain. In that domain, I know that x minus 1 has to be greater than 0. So I know my x is going to have to be equal to 1. And you're right, they both do have the base. This one has a base of 2, that one has a base of 2. They're on separate sides. So maybe I could add this over and then use my power rule. But maybe this right here, you know a little bit of that. I'll try that. See if it works. I'll try it, Cheyenne, see if it works. I could also try taking some Tylenol. I haven't done that. I'm just drinking coffee, hoping that'll fix it. I don't know why coffee might fix it, because I didn't have enough. This is just a fancy way to write a number, isn't it? Log base 2 of 4, isn't that just a number? It doesn't have an x in there. So instead of trying to get this log over there with that log, how about I just make that number what it is? What is that number? Yeah, that's just a fancy way of saying 2, right? Because 2 squared equals 4. So this number right here is just 2. That's really all that is? Because 2 squared equals 4. So that's just a fancy way of saying 2. It's not going to help. Obviously not. It's not helping. I'm going to try some Tylenol. Maybe that'll help. So now I'm just going to do this subtraction. 5 minus 2 is 3. So recognizing when you don't have an x in the argument, when there's not an x in there, look to see if you can just simplify it. See if you can find out just what that number is equal to. So that one didn't have an x in there, I can just find that number. Coffee's supposed to make everything better. All right, now I need this logarithm by itself. He's not isolated. This is going to cause the disease to spread. Isolate. So to isolate him, I'm going to divide off this 3. So I'm going to divide both sides by 3. So I have log base 2 of x minus 1 equals 1. Finally, when I get it where it's just a log and a base, an argument, and its exponent, now I can put it in exponential form. So when the variable is in the argument, your whole goal is to be able to put it in exponential form. So I'm going to take that 2 to the first power, and it equals x minus 1. Good, y'all got this. Then 2 equals x minus 1. Add 2 to both sides, and x equals 3. 3 minus 1 is 2. 2 to the first power gives me 2, so this is just a fancy way of saying 1. 3 times 1 is 3. Hey, that's what we wanted it to be. That is in the domain. It is greater than 1, so that is my solution. Okay. So when you have an exponential equation, when your variable is in the exponential spot, first try to set their bases equal, and then when their bases are equal, their exponents are equal. If you can't do that, then take the natural log of both sides. When you have a logarithmic equation, when your variable is in the argument, you want to use the exponential form to help you get that out of the argument. Okay, so those are tonight you're going to be looking at the logarithmic and exponential equations and solving for x. I'll be on Discord. Y'all hop on and we'll have a party and get this done and then get it turned in. Okay, now let me tell you about next week in the polynomials. The polynomials, there are 4 lectures over that. Normally we would do Monday, on Tuesday we would do 2 of them. On Thursday, we would do 2 of them. And then turn in on Saturday. But they're a little bit longer. I mean, they're just time consuming. Graphing, y'all have said it over and over again when we've been on Discord that the graphing takes time. And this is going to take time. I'm going to go ahead and start posting stuff for next week with the videos that I'm creating, so you can watch the videos to see how to graph it, and you could go ahead and get started. Then I'm going to go ahead and have your homework and your assessments due on, well, your homework anyway. Your homework's going to be due on Saturday, but the assessment part of it's not going to be due until Sunday. And that's because the assessment on it is going to be a little bit more than normal. You're going to have to make me a video that you upload to YouTube explaining how to work a problem. I'll give you the whole instructions and everything, but you're going to have to figure out how to make a video and upload it then to YouTube, explaining to me a problem. And I'll give the whole explanation so you'll step by step know exactly what to do. And then you're going to send me the link. When you do that, when you upload it to YouTube, be sure that there's going to be a box for you to click, is this for kids? The answer to that question is no, it's not for kids. You're not doing a little kids show. Even though we'd love for kids to learn all this, it's not for kids. It has to go under certain requirements if you say yes to that. And then you're going to send me the link for it. Also make sure that your comments are turned on for your YouTube video so that I can comment on it. You'll know that I've seen it once I comment on it. All right, so I'm gonna start posting stuff for polynomials. Don't get confused by that. That's all gonna be week 5 stuff. So make sure that you finish week 4 stuff first. It's due this Saturday. But once you get done with that, you can go ahead and start on week 5 stuff. And start busting it out. I'll go ahead and live stream on Tuesday, but really you should go ahead and get started so that Tuesday night can be more like if you have questions that you want to ask me. Also, we only have 2 more weeks. You're almost done. Really, just push through 2 more weeks. Next week is the hard week. Polynomials is time-consuming. It's not hard, it's just time-consuming. So you're going to push through next week, and then the last week we're going to work on rational functions, and it'll be a nice, simple week. It won't be that hard at all. We'll spend, really, both days would have been one night, because it's 2 lectures on rational functions. We'll split it up on the Tuesday and the Thursday, so that last week will be nice and easy. And some of you have gathered enough points at this point that you're getting really, you've already passed the class. So you're already getting to the point where you're like, okay, I just need this many points to get my A. So keep working hard to do that. So 2 more weeks. There's not a final exam. Push through these 2 weeks and we're done. You can do it. You can do it. Okay, so tonight finish up these logarithm and exponential ones. Well, I'll see you on Discord. We'll get that done, and then you can go ahead and start on polynomials. So my son's haiku really makes sense for today's thing. Press forward today that you might rest tomorrow. Well, in 2 weeks you can rest. Do your homework now. Now. Do your homework now. Now. Do it now. Hop on Discord right now. We'll talk. We'll have a party. All right. See you on Discord. Math Made Simple. It's some math. Thanks for watching.